As you can see from the title of this video, this tutorial is about learning combustion reactions. Combustion reactions are the fifth and final type of chemical reactions that we will look at as we go through the series of 5 that we're going to learn. And just like with the others, combustion reactions have a indicator, so to speak, so that you know what they are. All combustion reactions have the same characteristics. They are always some type of hydrocarbon plus oxygen. Some other indicators is that for these, the formula is given. The reason being, hydrocarbons are organic compounds, and despite the time that we have together, there isn't enough of it to learn how to do organic compounds in 1 year also. So we have to give you the formula for these things. The second thing is that occasionally you will see the word burns. That indicates we are working with a combustion reaction. The good thing about combustion reactions is their products are always the same. They are always carbon dioxide plus water. So if we were to take a look at an example, you would see something along the lines of methane burns. And you'll see underneath some of these organic names, parentheses that give you a formula, because it is telling you what the formula of that compound is, because you would have no way of knowing it otherwise. So here you have two indicators. There's a formula and it says burns. And anytime something burns, it means there has to be oxygen present. So what you really have here is CH4 plus O2. Then, the products of a combustion are always the same. You will always produce carbon dioxide plus water. Now it's just a matter of writing out your products. Carbon dioxide is a compound. Does it have prefixes? Yes. So we write what we see. Carbon dioxide is CO2, and water is a common. Last but not least, we would have to balance it. So I see carbon, hydrogen, and oxygen. We have to save H and O for last. So I see 1 carbon, 4 hydrogens, 2 hydrogens. So to balance that, I'll put a 2 here. 2 oxygens, and 2 plus 2 more oxygens is 4. So to get 4 O's to this side, I would put a 2 right there. Taking a look at a second example, how about we look at pentane plus oxygen. Pentane plus oxygen. The idea behind this is we want to first identify the type of reaction. These should stand out right away. A formula is given to me, I should know right away it's a combustion. The products of a combustion are always the same. Carbon dioxide plus water. Now it's just a matter of writing and balancing it. Pentane, they already gave us the formula for it, C5H12. Oxygen is an element. Is it a Hoberfinkel? Yes, so O2. Carbon dioxide is a compound. Prefixes? Yes, so we write what we see, CO2. And then lastly, water, right, is a commonly named substance. It is H2O. So, last but not least, we need to balance this. Again, carbon, oxygen, and hydrogen. I have to save hydrogen and oxygen for last. So then, I see 5 carbons on the left, 1 on the right. So to fix that, we'll put a 5 here. I see 12 H's on the left and 2 on the right. So to get there to be 12 H's on the right, we put a 6 here. Now we take care of our oxygens. 2 on the left. 5 times 2 is 10, plus 6 times 1 is 6. 10 plus 6 is 16 on the right. So to get myself 16 O's on the left, I put an 8 in front of them. Looking at one last one, what if we looked at octane plus oxygen? Identify type of reaction. As I look, octane would have a formula next to it, C8H18. That means it's a combustion. All combustions have the same products. Carbon dioxide plus water. So from here, it's a matter of writing and balancing it. Octane, formula is given, C8H18. Oxygen is O2. Carbon dioxide, CO2, water, H2O. Now I just want to balance this. I see 8 carbons on the left, 1 on the right, so we put an 8 here. Carbon is good. Then we move to hydrogen, second to last. 18 on the left, 2 on the right, so we have to put a 9 there, because 9 times the 2 is 18. Now we have oxygens, only 2 on the left. On the right, I have 16 plus 9, so I have 25. So I've reached an instance where there's no whole number that will go in front of O2 that will give me 25. So there's one of two things you can do. You can either try to find the LCF, or you can do the half method because O is last. When doing combustion reactions, the best way to do it is by the half method. So you have to ask yourself, what times 2 gives me 25? And the answer is 12 and a half. And then we don't like halves, so to get rid of it, we multiply everything through by 2. So there's a 1 here, so this becomes a 2. 12 and a half becomes 25. 8 becomes 16, and 9 becomes 18. When the coefficients get high like that, I always do a double check to make sure we're balanced. 2 times 8 is 16 C's, 16 C's. 2 times 18 is 36 H's. 18 times 2, 36 H's. 25 times 2 O's is 50 O's. 16 times 2 O's is 32 O's plus 18 more is 50 O's. I know when you usually get coefficients that are very high like that, you think you've made a mistake. That is in some ways true, but whenever you're working with combustion reactions, the coefficients can easily get up into the 20s and even at times 30s, right, 40s, and so on. One other thing I just wanted you to be aware of, there is a difference between burns and heated. Burns indicates combustion. Heated just indicates that it needs to have heat. Right? There's a lot of decomposition reactions that will be facilitated by adding heat. That does not mean we're burning it. Burning it is a sign of a chemical change. Heating is a physical thing that we do to the reaction to make it occur. So if you're having trouble with combustions, I hope this cleared things up. This wraps up the last of the types of reactions. So from here out, we'll be doing a lot of practice at recognizing types of reaction and then predicting, writing, and balancing equations. As always, if you're still having trouble, please feel free to come in for some help.